Hi guys, this is Mrs. Sekhali coming back with a new unit of the grade 12 university math advanced function, and we are looking at radians measures right now. So we are moving to finding angles in radians and then comparing, so basically doing some more trigonometry but now in radians. Angles are commonly measured in degree, and we know that, and we have dealt with degree for basically all of our math life, right? So that's what we've dealt with. We've dealt with measuring angles in degrees. However, in mathematics and physics, there are many applications in which expressing an angle as a pure number without units is more convenient than using degrees. So when measuring in, and this is what we call the radians. So when measuring in radians, the size of an angle is expressed in terms of the length of an arc A that subtends the angle theta. So basically, we express this angle theta with respect to its radians, or with respect to the arc that is contained within that angle. So where theta is equal to the arc length divided by the radius. So 1 radian is defined as a size of an angle that is subtended by an arc with a length equal to the radius of the circle. So remember that because the angle in radians, right, so the angle theta is equal to A over R. So if theta is equal to 1, right, then I have A over R, then that means A is equal to R, right? So which means, since A is equal to R, then 1 radians is when I have R over R. So replacing A with an R, which equals to 1. Now, how many radians are in a full circle? Or in other words, how many times can an arc length equals to the radius fit around the circumference of a circle? So remember that a circumference of a circle is 2 pi r. So if I have, so to know the full angle of a circle, what I have to do is so my arc length is going to be 2 pi r, and then divide that by r, and that's going to be 2 pi. So the angle of a full circle, which is we know it as 360 degrees, is 2 pi. And this is very important to understand how to switch between degrees and radians. So we know that 360 degrees is equal to 2 pi radians. So 1 degree is going to equal to 2 pi over 360, right? Which is equal to pi over 180. So 1 degree is equal to pi over 180, and this is what we're going to be using. So 1 degree is equal to pi over 180. So to switch from degree to radians, you multiply by pi over 180, sorry. Now 1 radians is, so if I want to know what 1 radians is, I'm going to bring the 2 pi over here, and that's going to be 360 over 2 pi, which is 180 over pi. So to switch from radians to degrees, you're going to multiply by 180 over pi, and that will give you the degrees. Start by converting the following common degree measures to radians. So to convert to radians, 180. So remember, you have to multiply by pi over 180, and that's going to give you pi. So we know 180 degrees is equal to pi. How about 90 degrees? So 180 multiplied by pi, sorry, that should be 90, not 180. Pi over 180, and that's going to give me pi over 2, because I'm going to simplify this, I'm going to be left with pi over 2. And this is going to be 60 times pi over 180. And then if I divide the 60 and the 180, that's going to give me 1/3, so that's going to be pi over 3. 45. So these ones you should know by heart. Okay, so when I say 45 degrees, you should know right away what the answer is. You don't even have to do the math for that. And then you should be writing radians for all of these. That's going to be 30. These are your special angles. So knowing these is very important. All right. So let's put these angles on this lovely wheel. So we start at 0 degrees, and then we go to, we're gonna use this one, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and then back to 360. All right, so now this is in radians, or sorry, this is in degree, and then we're gonna try to write it in radians. So 0 degrees, we know that this is 0 radians. Now, if I want to look at 30 degrees, we know that 30 degrees, we just found that, and that is pi over 6. And we just found that 60 degrees is pi over 3, and we found that, or let's do this instead of the pi over 3. So the way that we're going to look at this is that we are adding pi over 3 every single time, okay? So that's going to be 2 pi over 3, which is, sorry, pi over 6 every single time. So 2 pi over 6, which is pi over 3. 3 pi over 6, which is pi over 2. 4 pi over 6, which is, if I divide both of them by 2, that's going to be 2 pi over 3. 5 pi over 6, that I can't change, stays as 5 pi over 6. 6 pi over 6, which is pi. 7 pi over 6, which I can't change that. It's not simplified. 8 pi over 6. If I divide both of them by 2, that's going to be 4 pi over 3. 9 pi over 6, I can divide both of them by 3, and that's going to be 3 pi over 2. And then 10 pi over 6, which is 5 pi over 3. And then 11 pi over 6, that I can't simplify. And then 12 pi over 6, which is 2 pi. So you know that each one of these is equal to pi over 6, right? Which is, again, we talked about that as 30 degrees. So 30, 30, 30, 30, 30. I'm adding 30 every single time. And that's how we can find them in radians. We know that this angle 30, which is pi over 6, so I'm adding pi over 6 every single time. And that's going to be 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. And that's, you can simplify that to find it in simple form. Now we're going to do the same thing, but we're going to do it with 45 degrees. Okay, so that's going to be 0, 45. The reason why we didn't do them on the same is it's a different, you're adding a different angle first of all, and then it gets too crowded. So 90, then we have 135, 180, 225, 270, 315, and then 360. All right, so we have here 0, then we have pi over 4, then we have 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, which I can't simplify, 6 pi over 4, which is 3 pi over 2, and then 7 pi over 4, and then 8 pi over 4, or 2 pi. All right, so these are the special angles in both radians and degrees. You should know them, and you should be able to find them, and you should be able to know that when I say, for example, 3 pi over 4, that's equal to 135. All right, so convert each of the following degree measures to radian measures. So we're going from degree to radians. Again, we're going to have to multiply by pi over 180. And that's going to be, if I simplify, I can divide both of them by, I can divide both of them by 45. And that's going to be 5 pi over 4. 80 times pi over 180. I can divide both of them by, what's my highest common factor is 20. So that's going to be 4 pi over 9 radians. And then 450 times pi over 180. So I can divide both of these by, what's my common factor is 90, I guess, and that would be 5 pi over 2 radians. Okay, so you always have to report it to the lowest term, lowest fraction. So to convert each of the following radian measures to degree measures, remember that to go from radians to degree, you're going to have to multiply by 180 over pi. So it's going to be 2 pi over 3 times 180 over pi. So what we have here, the pi and the pi will cancel each other. And then I'm going to try to simplify the 2 over 3 times 180. So it's going to be 2 times 180 divided by 3. And that's going to be 120 degrees. So if I do 2 times 180 divided by 3. All right, now I have 9 pi over 4 radians, so that's going to be 9 pi over 4 times 180 over pi. That's how you convert from radians to degrees. The pi will cancel each other, and then you multiply the 9 times the 180, and then divide that by 4, and that's going to be 405 degrees. The 1 radian is going to be multiplied by 180 over pi, and that's going to be about 57.296 degrees. So what you're going to have to do here, you're going to actually have to multiply the 1 by the 180 and divide it by pi, which is 3.14, and then that will be your answer in degrees. So Suzette chooses a camel to ride on a carousel. The camel is located 9 meters from the center of the carousel. If the carousel turns through an angle of 5 pi over 6, determine the length of the arc traveled by the camel to the nearest tenth of a meter. So what we know here, we know that we have this, and then we are looking for the length of the arc. So we are looking for this here. What we know here is that the radius is equal to, so the camel is located 9 meters from the center of the carousel. So this is, let's say, this is where the camel is, and this is 9 meters. Okay, this is the center, and then the carousel turns an angle of 5 pi over 6. I should actually draw this a little bit better. Should be a little bit more wider. Let's do that. So this is where the camel started, so it's 9 meters from the center, and then this is the angle here, which is 5 pi over 6, and then we're looking for the arc. So we know that from the previous pages, we know that theta is equal to the arc length over the radius. In this case, I'm looking for the arc length, so that would be theta times the radius equals to the arc length. So that's going to be 5 pi over 6 times 9 equals to the arc length. And that would be, if I'm finding the arc length to the nearest tenth of a meter, so it's going to be 5 times pi. You actually use the actual pi button, 5 times pi divided by 6 times 9, and that's going to give you 23.6, and that's going to be in meters. All right. So as we've done in grade 11, we talked about special triangles, and we talked about how to use the special triangles with the angles and with the SOHCAHTOA. So in this case, we're going to do the same thing. So we're going to draw the 4590. Okay, so but that in radians, this is going to be pi over 4, and then these side lengths are equal, and they're 1 and 1, and then Pythagorean theorem says that this here would be the square root of 2, because if I'm finding this here, it's going to be a squared plus b squared equals c squared, and that's going to be 1 squared plus 1 squared, which is equal to 2, and then to find c, that's going to be the square root of 2. So this is how you find these answers. So this is the special triangle 45, 45, and 90. Now we're going to do the one with the 60, 30. All right, so to find this one, what I know is I know that the radius of the circle was 2, and then this was the half of it, so that's going to be 1. And then we were able to find this as square root of 3, and then remember that this angle right here is the pi over 3, or the 60 degrees, and this angle right here is the pi over 6, which is the 30 degrees. Okay, also we need to remember the unit circle, which is a circle that has a radius of 1. Use the unit circle to write expressions of sine, cosine, tan in terms of x, y, and r. So remember that for angle theta, right? So if this is your angle theta here, y is the opposite, x is the adjacent, and then this is the hypotenuse. So 1 is the hypotenuse. So with respect to sine theta is opposite over hypotenuse, which is in this case is y over r, and then since r is 1, so it's going to be y. So sine theta is y. Cosine theta is adjacent over hypotenuse, so it's going to be x over r, and then since the hypotenuse is 1, it's going to be x. So if you look at this point here, x and y, x represents cos, and then y represents sine. So if you guys look at this, right, we just found right here the answer, and then we said that sine theta is equal to y in a unit circle. So that means the point x and y, it represents the cosine and sine. And tan is opposite over adjacent, which is y over x. So on the unit circle, the sine and cosine function take a simple form. So that will be sine theta is equal to y, and as I explained above, and cos theta is equal to x. And then the value of sine theta is the y coordinate of each point on the unit circle. The value of cos theta is the x coordinate to each point on the unit circle. Therefore, we can use the point where the terminal arm intersects the unit circle to get the sine and cosine ratio just by looking at the y and x coordinate of the points. So we're going to fill out this special angle in the unit circle. So at 0, 0, so that's going to be 0, 0, 1, and then tan x is going to be 0. For pi over 6, it's going to be 1 over 2. So remember that we can use the triangles here, right? So that's going to be the pi over 6, pi over 3, and that's going to be the 1, 2 square root of 3, right? And then if I'm looking at pi over 6, sine of pi over 6 is opposite over hypotenuse, so that's 1 over 2. That's for cosine x is going to be adjacent over hypotenuse, so it's going to be square root of 3 over 2. And for tan x is going to be opposite over adjacent, which is 1 over square root of 3. You can also write it as square root of 3 over 3. Doesn't matter which one you use, I'm okay with either. And this is the pi over 4. So sine pi over 4 is opposite over hypotenuse, which is 1 over square root of 2, or you can write it as square root of 2 over 2. Cosine is also, it's adjacent over hypotenuse, which is also 1 over square root of 2, which is square root of 2 over 2. And then tan x is 1 over 1 because that's opposite over adjacent, so it's going to be just 1. For pi over 3, so if I'm looking at pi over 3 here, the opposite over hypotenuse, so that's sine, and that's going to be square root of 3 over 2. For the adjacent over the hypotenuse, which is cosine, that's going to be 1 over 2 And for tan, it's going to be the opposite over the adjacent, and that's going to be square root of 3. For pi over 2, remember that unit circle we're talking about here, right? So for pi over 2, and 3 pi over 2, so this point here is 1, 0. This point here is 0, 1. This point here is negative 1, 0. And this point here is 0, negative 1. And remember what we said earlier, that for the x and the y point, we have x as cosine and y as sine. Okay, so basically for each one of these points, we know that this is cos and this is sine. So this is where I got the 0, 1, 0 from for the 0 angle and for the 2 pi angle. Now for pi over 2, sine is equal to 1. So this is my sine, right? So that's going to be 1. Cosine is going to be equal to 0. And tan is sine over cosine. So that's going to be 1 over 0, and that's going to be undefined. For pi, remember, this is your cos, this is your sine. So sine of pi is going to be 0, cosine of pi is going to be negative 1, and tan is going to be sine over cosine, which is 0. And 3 pi over 2, cos is going to be 0, and sine is going to be negative 1. So it's going to be negative 1, 0, and then for tan, I divide negative 1 by 0, and it's going to be undefined. All right, so hope this is helpful and you understand how to convert between radians and degrees and vice versa.